Hello everyone, myself Dr. Varun Narayan Mishra, and I'm working as an assistant professor at Center for Climate Change and Water Research, Suraj Gyan Vihar University, Jaipur. Today we are going to talk about the application of remote sensing and GIS in environmental monitoring and management. So the entire lecture will be divided into three parts. That is having the first part, that is having the introduction of remote sensing, and in the second part we will discuss about the basics of GIS and GPS, and in the third part we will see what are the role and what are the applications of RS and GIS in environmental monitoring and management. So in the first part I am going to describe about the remote sensing process. So remote sensing is a kind of method, it's a technique that is used to gain some qualitative and quantitative information about any distant object without having any physical contact. We gather the information about different earth surface features. We gather the information about different types of phenomena over the earth surface feature without having any physical contact. It's a kind of looking over the earth surface feature without having any touch, without having any physical contact with the objects. It can also be considered as a science of obtaining the information about an object by acquiring the data with a device which is not in the direct contact with that object. So remote sensing may be considered as a earth observation. Okay, whatever the data we are gathering over the earth surface feature, it can be done using the teledetection, or you can call it in general term as a earth observation. Okay, so the data that is acquired by the remote sensing is more than a picture. It's a kind of image that is having certain spectral information that provides us the data over the earth surface feature for ongoing changes over the earth surface feature, for getting any kind of information about the natural phenomena or man-made activities. Okay, so remote sensing is a different way of looking. It's a continuous observation of the earth surface feature. We can identify and detect different objects over the earth surface feature, and it will help us to get the prior knowledge. It will help us to get the prior information about different features over the earth surface, and it can be considered as a artificial eyes. We can call it as a artificial eyes of the human in the space, because we are observing the earth, we are observing the earth surface features without having any physical contact at some distant location. So remote sensing is having different types of advantages. It provides us the synoptic coverage, means we can acquire the images, we can get the information over the larger area. Okay, then the second important advantage of remote sensing is repeativity. Repeativity enables us to get the data over the same area multiple times. That is very much useful for monitoring the changes. That will very much useful for monitoring the ongoing changes over the earth surface feature. For an example, the change in the forest cover, for urbanization process, or for the change in the glacial features. Okay, third advantage is that it provides the data beyond the visible region. Our human eyes can only detect the information in the visible portion of the electromagnetic spectrum, but the remote sensing satellites, the sensors mounted on the remote sensing satellites, can provide us the data in the multispectral mode, that we call it as a multispectral imaging. We can get the data over inaccessible terrains like dense forest, some glaciers. We can have the option to get the data over inaccessible regions where we cannot go frequently. And all the data sets that is acquired by the remote sensing are spatially registered, that is having some kind of spatial resolution. Spatial resolution is a kind of information, its ability of any sensor to get the information about different close objects on the earth surface feature. Okay, and in the next line, it is an excellent data source for landscape coverage, and it is having the option to get the information without any political boundaries. Okay, so this is the entire process of the remote sensing. First, we should have some energy source. Sun is a natural source of energy. The radiation coming from the sun, when it reaches to the earth surface feature, when it interacts with the target on the ground, after the reflectance from the target, the energy which is reflected from the target will be received by the sensor. These sensors are mounted on the satellite, and the received energy, the received reflectance information from the target will be again transmitted to the ground processing stations, where the information is processed in terms of some images. The reflected energy captured by the sensor will be processed in terms of some images that can be used for further analysis, that can be used for different applications like forestry, agriculture, for water resource management, for natural resource management and monitoring of different earth resources. So remote sensing is having wider application. It can be used for image processing, digitalization, then data extraction, pattern analysis can be done using remote sensing. We can use remote sensing data sets for surface modeling, digital terrain mapping and modeling can be done using remote sensing. And different feature extraction can be done using remote sensing technique. And also remote sensing data sets can be used for the extraction of digital elevation data. Digital elevation model is a kind of data that provides us the changes over the elevation on the earth surface, and remote sensing provides us the data about the land use land cover surface, land use land cover over the earth surface. So remote sensing basically answers these four basic questions, means how much or what kind of feature is there, what is the location of that feature on the earth surface, what is the shape and extent of a particular feature, particular area on the earth surface. It provides us the information about the area, boundary and lineaments, and how much change is there. If we talk about the earth observation, so remote sensing provides us the information about the ongoing changes over the earth surface feature, and what is the mix of objects, mean how many types of features are there. If we talk about the landscape is composed of different land use land cover categories, different land surface features. So remote sensing answers that how much or what kind of objects are there over the earth surface. So remote sensing works in two different modes. There are two different modes, two different remote sensing systems. First one is active sensor, second one is passive sensor. In active sensor, the sensor uses its own source of energy. But in case of passive sensor, generally we'll call it as optical remote sensing, in which the sensor uses the natural source of energy that is coming from the sun. So remote sensing works in two different modes. First one is active sensor, second one is passive sensor. For an example, when we use the camera without flash, it is considered as a passive remote sensing or passive sensor. But when we use the camera with flash, it means the camera is using the own source of energy to illuminate the target. That kind of remote sensing is known as active remote sensing, and the sensors are known as active sensors. So passive sensors and active sensors are used for remote sensing process. Both are having different applications, both are having different advantages and disadvantages. In the next slide, we see different types of sensors and types of remote sensing. So in the first type of remote sensing process, generally we call it as a passive remote sensing, or in general term, we call it as an optical remote sensing, in which the solar radiation, which is coming from the sun, and it reaches to the earth surface, and after interaction with the target on the ground, the reflected energy is captured by the sensor. That is known as optical remote sensing. Whereas second type of remote sensing is active remote sensing. In active remote sensing, the sensor produces its own source of energy. It's an artificial source of energy that is generated by the sensor itself. Then this energy will be transmitted towards the earth surface, and the energy will interact with the target on the ground, and the energy will be captured by the sensor. That is known as microwave remote sensing. In general term, we call it as a microwave remote sensing or active remote sensing. So we see there are two types of remote sensing process: passive remote sensing and active remote sensing. So whatever the data we are collecting through the remote sensing process it's a kind of energy that is coming from the object. That energy is a kind of energy which is either reflected from the target on the ground, either emitted from the target. What happens in sometimes the energy which is coming from the sun is absorbed by the features on the earth surface. Okay, so this absorbed energy will be emitted after some time, generally in the night time. So that kind of energy is known as emitted radiation. Whereas in reflected radiation, the energy which is directly reflected from the upper surface of the land, upper surface of the earth, that is, we call it as a reflected radiation. So in remote sensing, generally when we talk about the optical remote sensing process, there are two types of radiations that is captured by the sensor. First one is reflected radiation, and second one is emitted radiation. And third is active remote sensing. Active remote sensing process is a kind of image acquisition through the artificial source of energy. The sensor itself produces own source of energy, and it is transmitted towards the target, and it is back scattered it is reflected back and captured by the sensor. Then we call it as a active remote sensing, like radar, lidar. These are active sensors, whereas passive sensors are totally based on the solar radiation or the energy coming from the sun. So in this figure, you see the difference between different remote sensing processes. First one is visible and reflected infrared radiation. Second one is thermal infrared remote sensing process. And third one is microwave remote sensing process. So there are a different categorization of the energy source. Like in case of visible and reflected infrared, sun is considered as a radiation source. Then in the thermal infrared remote sensing, the energy which is absorbed by the sensor will be emitted after some time. That is, we call it as a thermal infrared. And in the microwave remote sensing, the sensor itself produces its own energy source. Okay. Then in case of visible and reflected infrared, we generally collect the reflecting energy. Then in thermal infrared, we use the radiating energy. And in case of microwave remote sensing, we use both radiating and the reflecting energy. So there are basically two types of remote sensing process, active and passive. Within the passive remote sensing, we are having visible and reflected infrared remote sensing. And second one is thermal infrared remote sensing process. And you see the level of reflected radiation in three different phenomena. In case of visible and reflected infrared, we are having high reflectance. Then in thermal infrared remote sensing, we are having less amount of the energy. That is, we call it as the emitted radiation. Okay. So in case of reflected infrared, we generally collect the data in terms of reflected energy coming from the target. Okay. So in remote sensing, we generally collecting the electromagnetic radiation, and this electromagnetic radiation is coming from the sun. And after reaching on the target, it interacts with the objects on the Earth's surface feature and will be reflected back and captured by the sensor. So in remote sensing, there are two types of energy sources are required. First one is solar radiation, that is a natural source of energy. It is used for passive remote sensing process like reflected and emitted remote sensing. And in second type of remote sensing, that is active remote sensing process, in which we use the artificial source of energy like radar and the lidar. Okay, so generally we can say that remote sensing is totally based on the measurement in a different part of the electromagnetic spectrum. We measure the information, we gather the information in different parts of the electromagnetic spectrum, starting from the visible, then near infrared, thermal infrared, and microwaves. So electromagnetic radiation is a kind of energy source coming from the sun. It is energy that is traveling from the sun towards the earth, and it passes through the space as a electromagnetic waves, that we call it generally as electromagnetic radiation or electromagnetic energy. So the range of electromagnetic radiation of various wavelengths and frequencies, that is extending from cosmic waves to radio waves, is known as the electromagnetic spectrum. So electromagnetic waves are having two components, that is electric field and magnetic field. The electromagnetic waves are transverse in nature, and it can travel through the space without having any medium. Okay, that's why the electromagnetic waves or electromagnetic radiation travels with the speed of light. Okay, and it is electromagnetic waves are a kind of vibrations in the electric and magnetic field, and these electric and magnetic fields propagates in the direction of the propagation with perpendicular to each other, that is having certain magnetic and electrical properties of the target. Okay, so when an electric field changes, so does the magnetic field, and this changing magnetic field causes the electric field to change. When one field vibrates, so other will also vibrate. So as a result, there may be the process of electromagnetic wave, or we can call it as a electromagnetic radiation, where electric and magnetic fields both are perpendicular to each other and travels with the speed of light in the space, that can be used for the information carrier in remote sensing process. Okay, so electromagnetic radiation is an arrangement of different wavelength intervals. So the arrangement of different wavelength intervals, a certain range of the wavelengths starting from shorter wavelengths to the longer wavelengths, are known as electromagnetic spectrum. So electromagnetic spectrum is having different components. It is having different wavelength intervals, starting from shorter wavelengths like gamma rays, then X-rays, ultraviolet, visible, infrared, microwave, and the radio waves. Now, when the electromagnetic radiation started traveling from sun towards the earth, so it has to pass through the atmosphere. It interacts with the atmospheric gases, atmospheric particles. Whatever the electromagnetic radiation that is coming from the sun, and before reaching on the earth's surface, it has to travel some distance through the atmosphere. So it travels 2 times through the atmosphere. Once when it is coming from the sun and reaching to the earth, and the second time when it interacts with the target, and again when it is going back as a reflected energy towards the sensor. So the electromagnetic radiation has to travel 2 times in the space. Once during its journey from sun to the earth, and second time when it is reflected by the earth surface feature, different targets on the ground, and going back to the sensor. So the particles and gases present in the atmosphere can affect these incoming radiation in the light, and such kind of interaction of the solar radiation and the reflected radiation from the target with the atmospheric constituent interfere with the process of remote sensing. So sometimes the remote sensing images, the remote sensing process are greatly affected by the atmospheric effects. So we should reduce the effects of atmospheric phenomenon on the remote sensing process on the satellite images. Okay, so when the radiation passes through the atmosphere, there may be 3 mechanisms. There may be the possibility of 3 mechanisms. Either the electromagnetic radiation will be absorbed by the atmospheric gases or particles, either it will be scattered in different directions, or it may be reflected through the target. It may be reflected through the gases and particles. So the atmospheric effect are based on the properties of the radiation, such as the magnitude as well as the wavelength and the abundance of the particles of the gases and different types of atmospheric pollutants and other gases present over the upper atmosphere. So depending on the particle size, depending on the wavelength, depending on the intensity of the incoming radiation, we may have different mechanism, different phenomena in the upper atmosphere. We can have the process of absorption, scattering, and the refraction. So this is the way how this electromagnetic radiation interacts with the target. Whenever the solar radiation coming from the sun interacts with the ground, before reaching to the ground, it is scattered by the atmospheric gases and particles, or it may be the process for absorption. Because of the absorption, the radiation that is coming from the sun will be absorbed and it will not reach to the earth's surface, but the energy which is scattered by the particles will be redirected into different path, and this will reach to the earth's surface, and some kind of radiation, some amount of radiation that can pass, that can transmit through the atmosphere, can reach to the earth's surface. This energy will be reflected from the target, and again it will be captured by the sensor, and then it can be used for further processing and analysis. Atmospheric windows are very important concept in remote sensing. Whatever the radiation coming from the sun before reaching to the earth surface feature, it has to travel through the atmosphere, because most of the energy coming from the sun will be absorbed by the atmospheric gases and particles. Only specific wavelength intervals, only specific wavelength ranges can pass through the atmosphere. So the wavelength intervals that can pass through the atmosphere are considered as atmospheric windows. Atmospheric windows are a certain wavelength regions of the electromagnetic spectrum that are partially or fully transmitted through the atmosphere. And now this can be considered as the remote sensing process. Whatever the energy that can pass through the atmosphere and reaches to the earth surface will be again reflected after the interaction with the target. After the interaction on the earth surface feature, it will be captured by the sensor. So these are the major atmospheric windows, or we call it as a different wavelength intervals, starting from ultraviolet. Ultraviolet is completely absorbed by the ozone gases and different atmospheric gases in the atmosphere, so it cannot be used for remote sensing process. Then some part of the visible portion can pass through the atmosphere, that we call it as a blue, green, and red infrared portion of the radiation. Some portion of the microwaves can pass through the atmosphere. Whatever the region showing in the green, these are the wavelength intervals for which atmosphere is transparent, means these wavelength intervals can easily pass through the atmosphere and can reach to the earth surface feature. That can be again reflected from the target, from different objects on the ground, and it will be captured by the sensor. So these are certain wavelength intervals. In ultraviolet and visible, then near infrared, we are having certain wavelength intervals. These wavelength intervals can be used for remote sensing process, because these wavelength intervals can easily pass through the atmosphere, and it can be easily captured by the sensor when it is reflected after the interaction with the target, after the interaction with the object on the Earth surface. Okay, so remote sensing is a kind of sun-synchronous process. It is known as a polar orbiting satellites. Remote sensing satellites are considered as a polar orbiting satellites, in which the satellite moves from North Pole to South Pole to capture the entire Earth, okay, in different strips. These strips are known as a swath. The swath is the specific area covered by the sensor on the ground. And it may vary from sensor to sensor. Some sensors are having the swath from 10 kilometers, some sensors are having swath 100 or 170 kilometers. So this is the way how this remote sensing satellite travels and captures the data through its process from North Pole to South Pole over the Earth surface. So this is the this animation is showing how these remote sensing satellites passes from North Pole to South Pole to capture the areas on the Earth surface in different strips. These strips are known as the swath, and as the Earth is also rotating beneath the satellite, so in this way, satellite are able to capture the Earth surface in different strips. So this is the entire process of the functioning of remote sensing satellites. It can also be considered as a polar orbiting satellites or polar satellites, because it moves from North Pole to South Pole to get the information about the Earth surface feature. The next slide, the remote sensing scanning system. Remote sensing also scans the Earth surface in two different ways. Like we can have the across track scanning, in which the satellite scans the Earth surface in the across track motion with respect to the motion of the satellite or the direction of the flight, in which you see that sensor is able to capture the information. Sensor is able to capture the images over the Earth surface in a cross track mode, that we call it as a cross track scanning. In a long track scanning, the sensor captures the data. The sensor captures the information on the Earth surface in the forward motion of the satellite. Satellite moves in the forward direction, and at the same time, satellite is capturing the images over the Earth surface. That we call it as a long track scanning. So there are two types of scanning mechanism in remote sensing. First one is across track scanning. Second one is a long track scanning. And both are used for remote sensing. Initially, with the development of remote sensing, most of the satellites are in the across track scanning mode. But right now, recently, most of the satellites are working in a long track scanning mode. So these are some application areas of remote sensing. Remote sensing can be used for agricultural mapping, agricultural growth monitoring, forestry, water resource management. It can also be used for glaciological mapping. It can be used to see the changes over the glacial features. The geosciences can also be used for remote sensing application. Land use, land cover analysis and mapping can be done using remote sensing satellites. We can use remote sensing approach for monitoring the atmospheric gases, for monitoring the pollution level over the certain area. And biodiversity conservation and habitat analysis can also be done using remote sensing approach. And very important, one of the important advantage of remote sensing, one of the important application of remote sensing is in the disaster management. We can use remote sensing in disaster management, mitigation and planning strategies. For an example, in case of flooding and forest fire or earthquake, we can use remote sensing applications. We can use remote sensing images or data sets to monitor the changes, to monitor the spreading of the flood, to monitor the spreading of the forest fire. So we can prepare better planning and mitigation strategies in case of disaster management. So remote sensing is having wider application in different fields, and we can use it for the betterment of the society and the betterment of the human well-being. Okay, thank you very much for this lecture. So in this part, we have discussed about the basics of remote sensing. In the next part of the lecture, we will see, or we will describe the basics of GIS and GPS. And in the third part, we will see the applications of remote sensing and GIS in various fields or various applications.